It's not a comet, and it's not from here. Just months ago, 3I Atlas was a faint greenish blur on the very edge of our solar system. Now it's a cosmic enigma, racing toward the sun at nearly 70 kilometers per second. It's shrouded in a coma so vast it dwarfs entire planets, and along the way it has turned a mysterious, deep red. But here's what no one saw coming. Its shifting colors make no chemical sense. The glow can flip from red to green without warning, and its core, its heart, remains completely hidden from our best telescopes. We only know it's somewhere between the size of a city block and a mountain. If 3I Atlas is now a reddish object, what does that reveal about its true identity? And what are we actually witnessing as this alien traveler barrels toward Mars and the Sun right now? 3I Atlas is hurtling through our inner solar system at nearly 68 kilometers per second. That's over 240,000 kilometers every single hour, fast enough to cross the distance from the Earth to the Moon in less than an hour and a half. To put that in perspective, that's about twice the orbital speed of Mercury, the fastest planet in our solar system. And it is more than 10 times the closing velocity of most long-period comets as they approach the Sun. This isn't a slow drift through space, it's a kinetic jolt. A visitor from far beyond the Sun's reach, plunging inward with an energy that dwarfs anything in our planetary neighborhood. The trajectory of 3I Atlas is hyperbolic. That means its path is not bound to the Sun. It's just passing through on a one-time visit. Its incredible inbound speed rules out any possibility that this object came from our own Kuiper belt or Oort cloud. Only a true interstellar traveler arrives with this much momentum, untouched by the slow looping orbits of our native comets. Velocity on this scale means the forces at play are immense. As Atlas barrels in, solar radiation and wind slam into its coma, stripping away material and charging particles at a rate we rarely get to see. The object's kinetic energy, driven by that incredible speed, is enough to vaporize surface ices and blast dust outward in a shock of activity. Every second, it covers a distance equal to the width of a small country. These are not the numbers we see in ordinary comet science. This is something else. A body moving too fast, too straight, and too powerfully to fit the mold of anything born inside our solar system. Wrapped around 3I Atlas is a dusty envelope so vast it almost defies imagination. Even our most powerful telescopes, Hubble, Gemini, the Nordic Optical Telescope, show only a faint glowing shroud with the true edge lost in the background of space. This coma, made of dust and gas swept out by solar radiation, expands outward for thousands upon thousands of kilometers, completely overwhelming any trace of the object's solid heart. At best, high-resolution imaging places the core at less than 5.6 kilometers across. But some estimates, based on how much sunlight the coma reflects, go as low as a few hundred meters, or as high as 50 kilometers. That is a spread of more than 2 orders of magnitude. The only certainty is that the nucleus is utterly dwarfed by its own outflow, hidden inside a haze that could be many times wider than the planet Mars. This kind of scale isn't just a spectacle. It's a profound measurement problem. Every attempt to pin down the core's size runs into the same wall. The coma outshines the nucleus by orders of magnitude, scattering light and masking the object's true shape and size. Even with the best data, astronomers are left with a huge range, not a specific number. If the core is on the smaller end of that range, it would be one of the tiniest interstellar objects ever detected. If it's on the larger end, it could rival the biggest known cometary nuclei in our solar system. Until a spacecraft can get up close, or a perfectly timed occultation reveals the interior, the heart of 3I Atlas remains a complete mystery, fueling debate over what exactly we're witnessing and what we should even call this thing. Inside the offices of the International Astronomical Union, the official name for 3I Atlas is a point of friction. Think back to when planetary definitions changed. The fallout from Pluto's demotion lingered for years. This time, with a rare interstellar visitor at the center of the debate, the stakes feel even higher. Social media amplifies every rumor, and science communicators are fielding questions from classrooms and newsrooms everywhere. Should we call it a comet? A planetary fragment? Or something entirely new? Without clear evidence, a premature rebrand could undermine public trust, muddying the important distinction between scientific speculation and established fact. So for now, the official guidance is steady. Wait for the data. Keep the story consistent, and prepare for the very real possibility that the next observation could upend everything we think we know. The first polarimetric images of 3I Atlas arrived in late July, and within hours, the data set off a storm of speculation. Dr. Tony Santana-Ross and his colleagues had just finished calibrating a series of exposures from the Nordic Optical Telescope. They expected to see the usual diffuse haze, a random, featureless cosmic fog. Instead, the maps plotted a clean, steep curve with a negative branch that dropped lower and sharper than anything in the astronomical catalog. The degree of linear polarization reached -2.8% at a phase angle of just over 6 degrees. That's a value more often seen in distant, icy bodies called centaurs than in comets. The inversion point where the polarization shifts from negative to positive landed right at 17 degrees. Again, a perfect match for objects from the outer reaches of the solar system, not the inner zones where comets typically roam. Santana-Ross remembers the moment vividly. They had barely enough time to catch the coma's characteristics before it evolved. Each new image was changing the story. But as the team pushed their analysis, searching for rumored concentric rings or shells in the coma, the maps remained stubbornly uniform. There was no sign of rings, no double-layered shell, just a homogeneous field of dust. Cross-checks with other powerful telescopes in Chile and Bulgaria confirmed the result. Any variation in polarization across the coma was below 0.2%, well within the margin of instrumental noise. The coma's structure was smooth, the polarization curve was dramatic, but the spatial maps gave up no secrets. But the absence of ordered rings didn't diminish the shock. The phase angle behavior alone set Atlas apart from everything else. That deep, narrow, negative branch pointed to dust grains that were larger and darker than those found in typical comets. They were possibly complex aggregates laced with organic compounds and ices, forged in the coldest, darkest corners of interstellar space. The scientific models built for our solar system's comets completely failed to reproduce the curve. The only way to make the models work was to borrow parameters from small, distant objects, like Pholis, a centaur. This left the team with a fascinating puzzle. An object that looks like a centaur, moves like an interstellar visitor, and scatters light in a way no comet ever has before. The evidence was clear, even if the underlying physics was not. For Santana-Ross and his peers, the real surprise wasn't in the absence of rings, but in the unmistakable signal that 3I Atlas refuses to fit into any of our standard cosmic boxes. Dust from interstellar objects is often imagined as a random mix of tiny grains, drifting through space, shaped by the gentle push and pull of sunlight and solar wind. But with 3I Atlas, the evidence points to something far less ordinary. That pronounced polarization curve signals the presence of large, irregular aggregates of dust. These aren't the compact, bright grains we're familiar with from most comets. Instead, they appear to be loose, fluffy, and complex structures, more like cosmic snowflakes than grains of sand. Their properties suggest they formed in a very different environment than our own solar system. This alien traveler is more than just a scientific curiosity. It's a messenger from another star system, carrying clues about its origin within its strange reddish glow and its unusual dust. As it continues its journey through our cosmic backyard, every new observation brings us one step closer to understanding not just what 3I Atlas is, but also the vast unexplored universe from which it came. Thank you so much for joining me on this journey to explore the mysteries of 3I Atlas. Have you ever looked up at the night sky and wondered what secrets the stars are hiding? Well, sometimes those secrets come to visit us. And right now, one of the most mysterious visitors our solar system has ever seen is hurtling towards the sun. It's called 3I Atlas, and it's breaking all the rules we thought we knew about objects from other star systems. For months, astronomers have been tracking this interstellar traveler, and what they've found is mind-boggling. Initially, it looked like a comet, but not just any comet. Its dust cloud, or coma, is made of porous, tangled webs of organics and ice. This structure scatters light in a way that tells us it comes from a very cold, very dark place, far beyond our own sun's influence. All the early data painted a clear picture. 3I Atlas was red, incredibly red. This deep crimson color, about 18% redder per 1,000 angstroms than most comets, was its interstellar passport. It was the signature of dust that had been bombarded by cosmic rays for millions of years, coated in complex organic molecules known as tholins. This wasn't just a rock. It was a perfectly preserved piece of another star's debris disk. The data was consistent across multiple telescopes. Polarization maps of its coma showed a smooth, uniform cloud. If this object had jets of gas erupting from it like a normal comet, or if it was surrounded by some kind of artificial field, we would see distinct rings or patterns. But there was nothing, just a smooth, featureless glow. It seemed that 3I Atlas was a natural, albeit rare, relic from deep space. Case closed, right? Not even close. On the pre-dawn hours of September 7th, everything changed. A photographer in the Namibian highlands, known for capturing rare celestial events, pointed their camera at Atlas. They expected to see that familiar deep red hue. Instead, what appeared on their sensor was shocking, a vivid, almost neon green. It was a color that simply shouldn't have been there. Within hours, the image sent a shockwave through the astronomy world. How could an object that was definitively red suddenly glow bright green? The immediate suspect for a green glow in comets is a molecule called diatomic carbon, or C2, which fluoresces when broken apart by sunlight. But there was a huge problem with that theory. High-resolution spectra taken just days before showed almost no C2 emissions. It was an absence that seemed to completely rule out the standard explanation. The scientific community scrambled for answers. Could it be other trace chemicals? Maybe a strange light-scattering effect from ultrafine icy grains? Or was it just a fluke, a weird glitch in the camera's sensor? The debate exploded online. The photographer released their raw files, and analysis confirmed it. The green was real. Other amateur astronomers in southern Africa reported seeing a similar greenish tinge, though none as dramatic as the original photo. Professional observatories quickly retargeted their powerful telescopes, desperate to catch a repeat performance. But they found nothing. The green had vanished as quickly as it had appeared, leaving behind a trail of baffling questions. Was this a temporary chemical outburst? A rare alignment of dust and light? Or the first sign of a cosmic process we've never seen before? 3I Atlas had just proven that it refused to be categorized, widening the gap between what we could see and what we could possibly explain. And the plot is about to thicken. This October, 3I Atlas is scheduled for a close encounter of the planetary kind. On October 3rd, it will pass near Mars, close enough for the fleet of orbiters around the red planet to get a front row seat. The teams behind NASA's MAVEN, Europe's ExoMars Trace Gas Orbiter, and the UAE's HOPE probe are gearing up for this once-in-a-lifetime opportunity. It's a high-risk, high-reward mission. The same dust that makes Atlas so fascinating could also pose a threat to these billion-dollar instruments. But the chance to get a clear image of an interstellar nucleus is too tempting to pass up. A single clean shot could finally tell us its true size, ending years of speculation. Right after its Martian flyby, Atlas will perform a disappearing act. Starting around October 21st, it will slip behind the sun from our point of view. For nearly a week, no telescope on Earth will be able to see it. It's a total blackout window, a period where anything could happen as it gets blasted by the sun's intense heat. Will it break apart? Will it have a massive outburst? We won't know until it re-emerges, just days before its closest approach to the sun on October 29th. This high-stakes game of cosmic hide-and-seek has fueled a storm of speculation. The strange behavior of 3I Atlas has even opened the door to more unconventional theories. Some researchers have wondered if the coma's perfect smoothness is more than just natural outgassing. What if the dust shell is a form of shielding? A kind of engineered cloak designed to protect the core as it travels through a star system. While there's no direct evidence for anything artificial, the object's refusal to fit into any neat box keeps the door open for even the wildest ideas. Is it a natural relic or something stranger? The story of 3I Atlas is happening right now, and the coming weeks will be critical. It's a race against time, distance, and the blinding light of our own sun. We stand on the verge of a discovery that could rewrite our understanding of the universe and our place in it. Whatever the next images reveal, one thing is certain. This mysterious visitor from another star has already taught us that the cosmos is far more strange and wonderful than we ever imagined. Thanks for joining me on this cosmic journey. What do you think 3I Atlas is? Let me know your theories in the comments below. And if you want to stay updated on this incredible story and explore more mysteries of the universe, make sure to like this video and subscribe to the channel. See you next time.